Hey guys, this is Mrs. Michek, and we're going to do some more calculations with pH and hydrogen ions and hydroxide ions. So today we're going to be talking about the autoionization of water. Auto meaning self. So this is the self-ionization of water, so water ionizing itself. So I wrote out the equation, water plus water. So water, again, ionizing itself. So you can see from the equation, ignore this part right here. Water is going to lose a hydrogen ion to the other water. That water then becomes H3O plus. Okay, so one of the waters was a hydrogen ion donor, and the other water was a hydrogen ion acceptor. The acceptor becomes H3O plus. We call this hydronium. So we get a hydronium ion and a hydroxide ion. So this is the self-ionization of water, or the autoionization of water. Something else that I want to point out to you, that chemically, hydronium and hydrogen plus, H plus, which you will see a lot. You can see it in this equation down here. Hydrogen plus and H3O plus are chemically the same. So I can show you an equation to kind of prove that to you real fast. Water is also, we could show water just breaking apart and becoming H plus OH minus. Okay, so H plus and H3O plus are chemically the same, and we can use them for our purposes interchangeably. All right. So for the equation that you're going to be using today, you need to know the formula for Kw. You looked at acid ionization constants and base ionization constants last week. So using the same type of formulas is how we get the autoionization constant, or the Kw, for water, which is where we have the concentration of H plus ions multiplied by the concentration of OH minus ions in solution, and we get the constant 1.0 times 10 to the negative 14th. I wanted to make a note for you here that these brackets mean concentration, specifically in molarity, or big M. Remember big M from solutions. So this is big M for molarity, and the units for that are moles over liters. All right, so this is the formula that we're going to be using. One great thing about acids and bases is that all of the formulas that you are going to be using are in your reference packet. It's these bottom, 6 formulas right here. The one that I'm looking at right here, or right now, is right here. Okay, so that's the formula that we're going to be using. So if you ever get lost in a calculation question for acids and bases, look on your reference packet and find a formula that involves what you are being asked about. Okay. So for our first question, what is the concentration of H plus in a solution with OH minus equal to 3.7 times 10 to the negative 9th molar? And then it wants to know, is the solution acidic, basic, or neutral? So we're going to use that formula where we have H plus multiplied by OH minus, and remember these are concentrations. So the concentration of H plus multiplied by the concentration of OH minus is equal to 1.0 times 10 to the negative 14th. we are given the concentration of OH minus. We are trying to find the concentration of H plus. In order to get H plus by itself, I'm going to divide both sides by the concentration of OH minus. All right, so now, plus. I have the equation 1.0 times 10 to the negative 14th divided by the concentration of OH minus is equal to H plus. And I'm going to come up here and I'm going to actually do that. So I've got 1.0 times 10 to the negative 14th. Divided by 3.7 times 10 to the negative 9th. And that's going to be equal to my H plus ion concentration. So when I plug that into my calculator, and when I plug these into my calculator, I usually put parentheses around each one. All right, and I get 2.7 times 10 to the negative 6th molar. Okay, so we've gotten the concentration of H plus, but we haven't answered the question, is the solution acidic, basic, or neutral? So we need to remember back to our previous equation, or excuse me, our previous video. Do we have more H plus or OH minus? So H plus is given right here. That was our answer. OH minus is right here. So which one of those is a larger number? I want you to be aware, or remember rather, negative 9th is a smaller number than 10 to the negative 6th. So let me prove that to you real fast, or not prove, but remind you of why that is. Okay, so if I do 2.7 times 10 to the negative 6th, I'm going to have 1, 2, 3, 4, 5 zeros, and then my 2.7. Okay, whereas if I have 3.7 times 10 to the negative 9th, that number would look like this. 2, 3, 4, 5, 6, 7, 8, 3, 7. So which one of those numbers is smaller? This second one for sure is smaller, and that's representing my OH minus concentration. So my H plus ion concentration is definitely bigger. If my H plus ion concentration is bigger, then this is an acid. All right, next question. Very similar. If you felt comfortable with the previous question, you can try this one on your own and check your answer at the end. All right, so this says, what is the concentration of OH minus in a solution with H plus equal to 4.1 times 10 to the negative 10th molar? So again, we're going to use our formula. H plus times OH minus is equal to 1.0 times 10 to the negative 14th. this time I'm trying to solve for OH minus. So I'm going to divide both sides by H plus. And I get the formula OH minus is equal to 1.0 times 10 to the negative 14th divided by H plus. I can plug into that formula. My H plus ion concentration is up here, 4.1 times 10 to the negative 10th. Plug that into your calculator, and again, I recommend putting parentheses around the top and the bottom. And I get 2.44 times 10 to the negative 5th. And again, our question asks us, is the solution acidic, basic, or neutral? So we need to figure out which one is greater, the OH minus concentration or the H plus ion concentration. Well, looking, our H plus ion concentration is to the negative 10th, and our OH minus concentration is only to the 5th. So our OH minus concentration is bigger. Remember, when our exponent is a smaller number, that actually makes it a bigger number. It's closer to 1. So if our OH minus concentration is bigger, it's going to be a base. If you're confused by that, I would look back at the video about the pH scale. All right, so that's about it for our calculations using H plus and OH minus. And let me know if you have any questions.